Welcome everyone to this explainer. When you look up at the night sky, it is so easy to feel incredibly small against that infinite black backdrop of the Milky Way. We are talking about 14 billion years after the Big Bang. And today, we're actually going to embark on a cinematic journey right through our own cosmic neighborhood. We're going to completely strip away those unimaginable distances and just look at the bare, awe-inspiring anatomy of our solar system. We're going to explore exactly how this massive, intricate machine actually works. So, what keeps these massive worlds locked in a perpetual dance? It's a question that has captivated humanity for literal centuries. Think about it. What keeps these immensely heavy worlds locked in this unending routine? They don't crash into each other, and there's no way they just go flying off into the endless void. Instead, they trace these perfect invisible tracks right through the vacuum of space. Well, today, we are going to uncover the immense gravitational mechanics at play here, totally peeling back the curtain on the silent, premium clockwork of the cosmos. Okay, let's dive into this. To truly grasp the sheer scale of this system, we have to stop thinking of it as a flat drawing in a textbook. Notice these sweeping angles we have side by side here. On one hand, you've got this vast horizontal expanse where the orbits ripple out like waves in a pond. But then, on the other hand, you have this dramatic vertical drop that shows the true three-dimensional depth of space. These angles really capture the staggering volume our system occupies. It's not just wide, it's a deep, surrounding gravity well where every single object is perfectly suspended. So here is the ultimate cosmic flight plan for our explainer today. First up, the central star powering the whole shebang. Second, the tightly packed inner planets. Third, the rocky frontier of the asteroid belt. And finally, we're taking a journey out into the deep freeze of the outer giants. Starting right at the heart of it all, look over to the left side of the frame at the blazing, massive sun. Currently right in the middle of its dramatic stellar life cycle as a yellow dwarf, it is literally impossibly huge compared to those tiny spheres trailing away from it. This intense, burning sphere of plasma is, without a doubt, the absolute king of our neighborhood. Its physical presence isn't just a source of light and heat, it is the ultimate anchor. Without its overwhelming mass constantly pulling inward, everything else would just scatter straight into the galactic wind. And because of this star's immense scale relative to the planets, it serves as a clear, inescapable gravitational epicenter. It completely dictates the rigid orbital paths of everything you see. And naturally, it operates as a blazing heat source, meaning the planetary tracks closest to it exist in a super harsh, intensely bright, and incredibly hot environment. Now, what's really interesting about this slide is how tightly clustered those first few orbital paths are. These are our inner rocky worlds. From the crushing toxic heat of Venus to the freezing, cold, rusty deserts of Mars, they hug intimately close to the sun. Because they're caught so deep in that gravitational pull, their orbital tracks are incredibly tight and very fast. They're small, they're dense, and they were forged in the absolute intense heat of the inner solar system, all crowded together in the brightly lit shallows of space. And right down here, prominently in the bottom right foreground, we find something incredibly familiar to us: the blue planet and its orbiting gray moon. Seeing Earth placed in this giant macro scale really connects this terrifyingly huge system right back to humanity's delicate place in the cosmos. We are really just one fragile node riding along one of these glowing inner tracks. But as we push further out, we hit the asteroid belt. Now, contrary to all those science fiction movies, you wouldn't actually have to vigorously dodge and weave through it in a spaceship. It's mostly empty space, actually, but it acts as a massive, circulating ring of rocky debris. It's a literal dividing line, basically a cosmic fence separating the warm, crowded inner solar system from the cold, really expansive outer depths. And this brilliantly illustrates exactly what we're talking about. Look at that majestic, sweeping curve of illuminated rock and dust just cutting across the dark. It's like a giant cosmic river of rubble, constantly flowing in a massive circle around the sun. This great divide shows us that the solar system isn't just empty space between planets. It's filled with dynamic, moving structures that tell the origin story of how our cosmic neighborhood was formed. Crossing that rocky divide changes the rules of scale entirely. We're totally leaving behind the densely crowded, tightly clustered orbits of Earth and Mars, and we're entering a realm of vast, majestically spaced out orbits ruled by the gas giants. The outer system is for sure an entirely different beast. As your eye moves down this dramatic vertical view, you really have to marvel at these massive gas giants dominating deep space. From Jupiter's violently raging storms to Saturn's magnificent sprawling ring systems, these planets command absolutely huge swaths of the outer dark. Out here, the distance between the orbital tracks is just staggering. They essentially hold their own gravitational courts far, far away from the intense heat of the central sun. And the scale out here just shifts dramatically. The physical visual distance between these giant worlds is immense. I mean, it would take a spacecraft years, or even decades, to bridge the gap between these outer orbital tracks. The planets themselves are heavily magnified in size compared to the tiny rocky spheres of the inner system we started on. It's completely a realm of giants, moving slowly out in the cold dark. Let's move to and see how this builds. When you pull back to see it all at once, you notice the beautifully clear, concentric elliptical paths painted across the darkness. This is the clockwork orbital dance. Despite the massive differences in size, composition, and distance, from the tiny inner rocks all the way out to the sprawling gas giants, they are all perfectly organized into one cohesive system. It is a flawless mechanical harmony born entirely from physics. It is perhaps best described like this: a delicate, majestic balance of gravity and momentum. The sun's gravity pulls everything inward, while the sheer speed and momentum of the planets try to fling them out into deep space. And the result of that eternal tug-of-war is this perfect, mathematically balanced elegance. It is literally mathematics made visible on a cosmic scale. Taking in this vast cosmic neighborhood in its entirety, from the blazing inferno of the central star, across the rocky tracks, through the great debris divide, and way out to the majestic rings of the distant giants, you realize every single element is exactly where it needs to be, moving with relentless, silent precision. It is an incredibly awe-inspiring place to call home. Just take a moment to let the scale of that sink in. Which leaves us with one final, totally thrilling thought. As we observe our tiny blue planet's place in this intricate orbital clockwork, we absolutely have to wonder, when we look past the furthest giant, way out toward neighboring galaxies like Andromeda, what other delicate, beautiful systems might be hiding out there in the vast dark? Keep looking up and never stop questioning what lies beyond.